All right, everybody. So what we're going to be doing in the live lesson Wednesday and Thursday is looking at a project that we're going to be doing in the live lesson that deals with similar figures. I'm going to go over a quick review here of what similar figures are. Okay, so in this module, we've been learning about ratios and how they relate to each other. They're a set comparison between two numbers. Similar figures are kind of the same thing, where we're saying that there's a ratio that compares, in this example, the big rectangle to the small one. And if we start under the premise that these two figures are similar, I can actually set them up and figure out missing information. What does this mean? Well, if I'm looking at this problem here, the length of this rectangle is 20 feet. The length of the small one is 8. That tells me that I have a ratio between these two similar rectangles of 20 feet to 8 feet. Now, what else does this tell me? This tells me that if these triangles are similar, or not triangles, rectangles are similar, then the other sides are also going to keep that same ratio. So that means that this 4-foot side is going to carry the same ratio to the side that I don't know. And using this information, we can actually solve for that missing side. How do we do that? Well, we know that any ratio can be written as a fraction. So this 20 feet over 8 feet, I can take this and say, okay, the length of the big triangle is 20 feet. And the length of the small triangle is 8 feet. And whatever this ratio is, that ratio has to hold true for the other side. So I'm going to take this and throw this into my equation now too. The width of the large rectangle is 4 feet, and I don't know the width of the small one. Now I have two ratios set up and I can solve them. So let's go ahead and go about this and see if we can figure this out. If I look at this, I can see, first off, my variable's on the bottom. And we should remember a trick that we learned, that 1 over 3 equal to 1 over 3. If I flip both sides of the fractions, I'll keep it the same. It would just turn into 3 over 1 equals 3 over 1. I'm going to use that trick here as well. I'm going to say, okay, I'm just going to flip this so it becomes easier to work with. So I'm going to flip this one to be 8 over 20. And I'm going to flip the other one to be x over 4. Now, why would I do that? Well, now I have a problem that I know how to solve. I see I have x being divided by 4, and if I want to solve for that variable, I need to cancel the divide by 4, so I multiply both sides by 4. And I would see that the 4's on this side cancel. They leave me with the x equals, and now I have to figure out what's 4 times 8 over 20. Well, 4 times 8 is 32. The bottom stays the same, so it's 32 over 20. Now we're dealing with feet. It doesn't make sense for us to keep fractional feet. So I can just go ahead and do the division here and get my decimal form, which is something we learned way back in lesson 1 of this module. So divide this by 20, I get 1.6. So the missing side is 1.6 feet. So using ratios and proportions, I found out that this side of this rectangle is 1.6 feet. Okay, now that's an example of similar figures. We're going to be looking at the following problem in the live lesson. Okay, we have Tyrese is planting a garden for his backyard. He is first drawing the garden on a piece of paper, and then will construct the garden later in his backyard. In his drawing, the length of the garden is 2 inches. The width is 8. He knows his backyard is 20 feet wide, and he wants to leave 2 feet on each side of the garden to be able to walk around. Okay? the two questions we're going to be answering: if he constructs his garden to scale of his drawing, what are the dimensions of his garden? So we need to figure out what the real life dimensions of that garden are going to be with the conditions they set in the problem. B, he plans on the area of the garden being 30% flowers, half of it vegetables, and the remainder to be bushes or trees. What would the area for each of the three sections of Tyrese's garden? Here's your task to get ready for the live lesson. Set up a drawing of similar figures to get ready for today's project. So you need to come up with what the drawing would look like, just like we did over here. So you'd have two different rectangles. One would be the drawing, and one would be the real life. So we want to see if you guys can get together the drawing of the scenario, okay, and bring it ready for class. If we make any mistakes, we'll correct it before we get started. Also, we want you to identify any problems or concerns we may have to address to answer questions A and B. Okay, so here's your problem for today. I zoomed out here so you guys could see it, and copy it, share it, do whatever you need to do. Keep the video up until you finish, and we will see you guys in the live lesson.